Hello, so this is a revision video for IB Chemistry S2.2.9, Physical Properties of Covalent Substances. For substances of comparable size with similar molar mass, the strength of intermolecular forces follows this order. London dispersion forces are weaker than dipole-dipole forces, and dipole-dipole forces are weaker than hydrogen bonding. The bonding and intermolecular forces present in covalent substances explains their physical properties, such as volatility, solubility, and electrical conductivity. Volatility is the tendency of a substance to vaporize. A substance is more volatile if its intermolecular forces are weaker, because less energy is required to overcome the forces between them, meaning it's easier to turn them into a gas. Stronger forces require more energy to overcome, leading to higher boiling points and making it harder to vaporize. For example, H₂O has a melting point of 0 degrees Celsius, whereas H₂S has a melting point of minus 85.5 degrees Celsius. This is because H₂O has hydrogen bonding between its molecules, which are stronger than the permanent dipole-dipole interactions between H₂S molecules. The stronger attraction requires more energy to overcome, meaning H₂O has a higher melting point. Solubility refers to how well a substance dissolves in a particular solvent. Whether or not a solute dissolves depends on the intermolecular forces between particles of solute and solvent. The general rule used in chemistry for solubility is like dissolves like. Polar molecules dissolve well in polar solvents via dipole-dipole or hydrogen bonding. Nonpolar molecules dissolve in nonpolar solvents via London dispersion forces. As well as dissolving ionic compounds and small polar molecules, water also dissolves some molecules that can form hydrogen bonds, such as ethanol and ammonia. It is the high relative strength of these hydrogen bonds that can form between these solute molecules and water molecules that make them soluble. In other words, the strength of hydrogen bonding that can form between the solute molecules and water molecules is comparable in strength to the strength of hydrogen bonding that can form between just water molecules. Exam tip here. Whether a substance dissolves in water depends on the relative strength of interactions between solute and water molecules compared to the interactions within the solute itself and within water. For example, ethanol is soluble in water because the intermolecular forces between ethanol and water molecules are similar in strength to the forces between only ethanol molecules and only water molecules. These comparable attractions make it energetically favorable for the substances to mix. Water is a poor solvent for large molecules that cannot form hydrogen bonds, for example halogenoalkanes, and nonpolar molecules, for example iodine and hydrocarbons. These substances cannot interact favorably with water's hydrogen bonding network and are therefore insoluble or only partially soluble. This means it is more energetically favorable for water molecules to simply hydrogen bond to each other rather than mix with the solute molecules. For substances that don't dissolve in water, non-aqueous solvents can be used. These solvents don't rely on hydrogen bonding and instead dissolve substances through London forces or dipole-dipole interactions. Solubility in these solvents depends on matching the type of intermolecular force. Covalent substances typically don't conduct electricity because there are no free electrons or ions that can move and carry charge. Graphite is an exception to this because it contains delocalized electrons between the layers that make graphite a good conductor. Molten acids or solutions of covalent acids can also conduct electricity due to ionization in water, but this is covered in a much later topic.